Hello class, this is the video for section 4.5, and in this we will be solving polynomial and rational function inequalities. Okay, so polynomial and rational inequalities, right? There are two objectives. It's very simple: solve polynomial inequalities and then solve rational inequalities. We will look at two approaches: by graphing, and also by what? Solving it algebraically. All right. So first, let's to consider a polynomial function where we want to solve the inequality by what? By graphing. Okay. So we want to solve the polynomial s with the factors x plus 4 times x minus 3 all squared is greater than what? Greater than what? 0. Now remember, to solve the inequality, you make sure that always the right hand side, okay, is what? It's this 0, it's in this form. Okay. So in this case, what is our polynomial function? That's f of x is equal to the left hand side. So to graph this, we have to find the x-intercepts. We want to know the domain, the x and y intercepts. You want to know where the end behavior of it, the degree, the number of turning points, like we did in section 4.3. Okay, so I'm not going to go through all the steps and graph it. I'm just give you the graph and then explain how we can relate it to what the inequality part of it. All right, so now to graph this function, okay, you determine the y intervals of x, okay, because it is greater than, which the graph is above the x-axis. And then the function is either positive on these what intervals. Now, it does not matter if it is what less than, then to be what? Below. It was expected to be negative and then below the what? Below the x-axis, okay? Below x-axis. Now, if you have the greater than equal to, then it is going to include those values. In other words, you're going to use brackets instead of what? Parentheses when you graph the solution set. Okay, so here's the graph. Okay, our f of x, remember, if f of x is what? X plus 4, okay, and then x minus 3 all squared. All right, so if you want to graph this, what is the degree? What's the degree? We have what? X, you have x plus 4, and if you expand the other one, you have what? X squared minus 6x plus what? Plus 9. And so this gives me x cubed. All right, talking about the end behavior, it's an odd function, so it's going to rise up and it's going to fall like that. Okay, now the zeros, the x-intercepts are -4 and then the +3. But in terms of their multiplicity, this is 1, so the graph crosses at what? X equal to -4. It is a multiplicity of 2 for the other one, so it touches it. Okay, and then you plot few points, and that's why we have what? We have this graph. And so the inequality was that f of s is greater than what? 0. Now we look at the portions of the graph where it is above the x-axis. Now, as we can see, between this portion of the graph, okay, it is really what? Above the x-axis. In fact, this point, it kind of touches it, but after that, it what? It goes above it. So that is why it does not include. Okay, so what are the x intervals of x? So it's from what? -4 to 3, and then 3 and all above. Okay, x is greater than what? Greater than 3. So what is this? Where does it show that? And that is the values of what? X. Okay, and then therefore the solution set in terms of set notation is x such that x is greater than -4 and less than what? 3, or x is greater than 3, as we can see. If the portions of the graph where it is above the x-axis. And if you use interval notation, that's what you got. Okay. Then if you want to graph this, if you want to grab the solution set, okay, you have what? Negative 4, negative 4, and you have what? You have 3, okay, at 3. Okay, so between this, you have, this is going to be parenthesis there, and that will be parenthesis, and then you have parenthesis going that way. So you have this, and then between what? Between that. Okay, so here you have 2. It's opens to the left because it doesn't include the what? The 3, and doesn't include the what? The negative 4. So you have parentheses on both ends. Okay. Now here's another example. We want to solve this algebraically. Solve this inequality algebraically. S to the 5th greater than what? Negative x squared. Okay, and then we'll grab the solution set. Okay, step 1, rearrange. Okay, rearrange and then simplify. So rearrange the word inequality so that 0 is on the other side, and then we'll simplify if what necessary. Okay, simplify if necessary. We'll see that in the next example. Okay, so what we have there, we have what? To rearrange that, that means you add what? X squared to both sides. So you have what? X to the 5th. Okay, x to the 5th plus x squared greater than what? Greater than 0. Okay, so we need to factor this. Okay, this inequality again is equivalent to what? To the original that we have there, to the one we have above in solving. That was the original equation. So we want to determine the zeros. Okay, we want to determine the zeros. Step 2, determine the zeros of f of x. So we want to find the function is at this. So my f of x is there what? X to the 5th plus what? X, and we set it to 0. That is finding the zeros, right? Okay, so in solving for that, okay, we need to what? Factor the what? The polynomial. And this is how we go about it. So what's a common factor to the left? Well, now we have what is s squared outside. I'm going to divide this page into 2. It'll be s, I was going to have what? S cubed plus 1 is equal to what? It's equal to 0. Now, don't forget that if I have x, the sum of cubes, okay, if you have the sum of cubes, this is 1, is what? S cubed plus what? 1 cube, and that is given by what? X plus what? Plus 1, and the s squared minus x plus what? 1 squared. Okay, now I'm using this, okay, s squared minus xy plus y squared. Okay, this is for what? S cubed, sorry, s cubed plus what? Y cubed is equal to that. Okay, so when you factor this, you have x squared, and that gives you x plus 1, and then s squared minus x plus 1 equal to 0. So that means s squared is equal to 0, or x plus 1 equal to 0, or x squared minus x plus 1 equal to 0. Of course, x equal to 0, x squared equal to 0 means that x is equal to 0 for that one. And then x plus 1 equal to 0, meaning that x is equal to negative for negative x. All right. Okay, so x is equal to negative x. So then we need to solve this using it's a quadratic equation. So let's check the discriminant. Okay, so let's do the discriminant here. The discriminant is what? Write it well. So that's a discriminant is what? B squared minus 4ac. Okay, according to this, a is 1, b is negative 1, and c is equal to 1. So that is 1 squared minus 4 times 1 times 1. And that is what? That will give me negative 4, negative 3. So it means that I'm going to have, if I want to solve the solution, this equation, that is the x squared minus x plus 1, I got minus 1, okay, plus or minus the square root of negative 3 over what? Over 2 times 1. And then because of this part, it has what? Has no real what? Solution. Has no real solution. So the only zeros that we have are what? The only zeros we have there are what? The only zeros are x is equal to 0 and negative 1. Okay. So that's step 2. Now step 3 is I use the 0 to separate the number line into what? 3 intervals. Remember, it separates it into what? N plus 1 intervals, where n is what the number of zeros you have. So if you have 3 zeros, it will separate the number line into what? 4. If you have 5 zeros, it will separate into what? 6 intervals. So we have from negative infinity to what? To negative 1, and from negative 1 to 0, and 0 to what? Positive infinity. So we have that. Okay. Then it says for each interval, all right, select what? Select a test value, we call it the test number, and then test it on what? The f of x. So where it is what? Positive, determine where it's positive or negative. And then your equation is that you want to find where it is what? It is positive. Okay. So we have that. Now, what we do is that I'm going to draw a number line. Okay. And I have what? I have negative 1 and I have 0. Okay. So I'm going to use a test value for the first interval from negative infinity to negative 1. Let's use, say, negative 2. And then between this, we're going to use, say, what they call negative 0.1, say 5. And then here, let's use 1. Okay. This is the sign of what? The f of x, which is what? X to the 5 plus what? X squared. Okay. So if x is what do you call it? X is negative. Okay. X is negative what? Negative 2. All right. So you want to evaluate the function at what? Negative 2. All right. Which will give me, all right, this will be minus 32 plus 4. That is negative. So this part is what? Is negative. So I put negative there. And if I plug in negative what? 1/2, negative 1/2. So let's find negative 1/2, which is 0.5. This will give me negative 1 over what? 32 plus 1 over 4. Okay. And what will be the sign? If you simplify this, you just want the sign. So this is going to be 32. Okay. The denominator, and you're going to have for same that is minus 1 plus 8. All right, that's going to be positive. So this part is positive. Okay. And then if x is 1, if you use 1, that is going to be what? Also positive. Okay. So you see that where the function, want to find a function where f of x is what? Greater than 0. Okay. So with that, we can say that, okay, we can say that the intervals, all right, for, remember it was x to the 5th less than, that was original, x squared, and then we simplify this into what? X to the 5th plus what? X squared less than 0. And so let's go back and let me check that. Was it greater than, sorry, it was greater than that's what it was, I don't know why I was saying that. It wasn't, sorry. So this is supposed to be greater than. Okay. So you have, this is what? This is greater than, that's original, and greater than 0. So with the positive part. So which interval will satisfy where the f of s is what is positive? The sign of that it's going to be just between -1 to 0, okay, and then 0 to what? Positive what? Infinity. Okay, so when we go to construct it, the solution set of the inequality is what? Is that, or that is x is what? Between -1 and 0, straight inequalities, and x greater than what? Or x greater than 0. And then the interval notation is that. And then we can graph this. We graph the solution set, which is that. So between this is -1 to 0. We got parentheses, and then parentheses open to the right of at 0 to what? To positive infinity. Okay. Now we can solve this. We did one example polynomial using graphing, okay, and then algebraically. Now let's go to rational function, and then we were gonna do using graphing and then also um, algebraically. So, but for this particular example, okay, where you have x minus 1 over x squared minus 9 greater than or equal to 0, I'll solve it in the two ways, by graphing and by algebraically. All right. Okay. So this is our rational function. We want to solve, we want to graph this and determine the intervals of x for which what, because it was strictly greater than or equal to 0, it has to be above the what? The x-axis. Okay, so the function r is non-negative on these what intervals. In other words, it is positive. All right, so let's go to the steps. We graph it. We know how to graph this, right? You have to do this and factor this. Will be x plus 3 and the x minus 3. Okay, we have to find the asymptotes, the x-intercept, y-intercept, the asymptotes, and the asymptotes will be what? The vertical asymptotes will be -3 and +3. All right, but what's the horizontal asymptote? Because this is the degree is 1, numerator is 1, the denominator is 2, it is less than that. So the line y equal to 0 is what is your horizontal asymptote. Your vertical asymptotes are what? X is equal to -3, x is equal to what? +3. All right, so we know how to do this from section 4.4. Okay, so we want to graph this function. Got my vertical asymptotes, right? Then the vertical my horizontal asymptote is what? The line x, y equal to 0, or the x-axis. Okay, so when we graph this, okay, when we graph this, we have what? This kind of graph. So where does it, okay, the function is greater than or equal to 0? Well, it is positive between what? Right after the vertical asymptote to the right, up to 1, and then after what? After 3. Say, so the solution set will be portions where it is above the x-axis. So this portion, it is above the x-axis, and it's above the x-axis all the way until it hits what? +1. Okay, and then we have that. Okay, so the solution set is what? X is such that x is what? Less than or equal to 1, okay, but greater than what? -3. Why? Because -3 is a vertical asymptote, so you cannot include that. Cannot include the -3, and then also you cannot include the what? +3, because it's also a vertical asymptote. All right, so in this case it is what? Less than half. If you draw the graph of the solution set, there will be bracket on the +1, but parentheses on what? The -3 and +3. Okay, so the interval notation form of that will be that from -3 to what? To 1, not 0. Okay, to 1. All right, and then from 3 to what? +infinity. Okay, so that was a term. So the graph in this case would be what? I think I have it there. No, let's do it. Say you're gonna be this. Okay, you have what? You got -3, you have 1, and then you have what? Positive 3. So it's going to be parenthesis and brackets, and then what? Parenthesis. Okay, it's going to be between that. And then there's to positive infinity. All right, so now we want to solve the same thing algebraically. Solve algebraically and graph the solution set. Okay, how do we solve? First, rearrange the word inequality and simplify. Well, already we have the 0 on the right hand side, so it's already rearranged. Okay, already rearrange. Okay, do we have to simplify it? No, because this is just, suppose I had like 1 this over x squared minus 9, say plus 1. That's when we move it, but we'll see an example in the next one. I'll do an example in the next one. So let's leave it like that. Okay, that's step 1. Now step 2 is to determine the zeros of the f and the rare numbers for which it is what? It is undefined. Okay, now what are the rare zeros? Okay, what are the rare zeros? So we have the x minus 1 over what? X squared minus 9. All right, less than, sorry, greater than, equal to 0. Now this is what? X minus 1, and you factor the denominator, you have x plus what? 3, and the x minus what? 3, greater than, equal to 0. So your f of x in this case is what? X minus 1, x plus 3, x minus what? 3. Okay, so when x is equal to 3 or minus 3, the denominator, the function is undefined. So let's first find the zeros of the numerator. Okay, and the numerator, that is x minus 1 equal to 0. You have x is equal to positive 1. And then the zeros of the denominator, okay, denominator, that is where the function is what? Is not defined. So you have x plus 3, x minus 3 equal to 0. You get x is equal to minus 3 and then positive 3. Okay, so there are 3 of them. It's going to divide the real number line to how many what? How many intervals? 4. We got 1 from negative infinity to negative 3, from negative 3 to 1, 1 to 3, and then 3 to what? Positive infinity. Okay, so then like we did, we're going to draw a number line and test that and determine where it is what? In this case, it is what? It is positive. Okay, it is positive. That will be those that will satisfy. So select the test number and do that in step 4. Okay, so we got negative 3, we have 1, we have what? We have 3, and then to infinity. So I'm going to use the test value for each of them. Let me change my color. All right, by the way, we have what? Let me put a function here. This is the sign of what? F of x. And what is f of x? F of x minus 1 over x plus what? 3, x minus 3. Okay, just the sign of that. So if I use minus 4 for this interval from minus infinity to negative 3, and then we have for negative 3 to 1, we have 1 to what? 3. Okay, and then we have for 3 to what? Positive infinity. So if I use minus 4 for that, if I use 0 for this, if I use 2, and if I use 4, okay. Now we're going to test on your f of x right here. So if x is negative 4, see that the numerator, okay, let's do it over here. X is negative, for the numerator is negative, right? Because minus 4 over minus 1 is negative. And then negative 4 plus 3 is what? Is negative. And then negative 4 minus 3 is also negative. So negative over positive is what? Is negative. So this part is negative. And then when x is equal to 0, what do you have? Okay, the numerator is 0, so we have 0 minus 1, which is negative, minus 1. And then 0 plus 3 is positive. And then 0 minus 3 is negative. So negative over negative is positive. So this is positive over the interval. And if I use 2, I'll have what? 1, which is positive in the numerator. The denominator is also x. 2 plus 3 is what? Positive. And then 2 minus 3 is negative. So that is what? That is negative. Okay. And the x is equal to 4. The numerator will be positive because 4 minus 1 is positive. And then you have 4 plus 3 is positive. And then 4 minus 3 is also positive. So this is positive. Okay. Now remember, we want to find the what? The inequality, solving the inequality, x squared minus 9 greater than or equal to 0. So the intervals that satisfy that inequality, okay? So the solution set, okay, the solution set will be, I'm writing an interval notation. It will be from what? Minus 3, okay, to what? To positive 1. Now, but positive 1 is not a vertical asymptote, but negative 3 is, even though this is greater than what? Equal to union what? 3 to what? To positive what? Infinity. Okay, so that gives us the same as what? Same as before. And then if I withdraw the what? The 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 graph of the solution set, the graph of the solution set will be this. Okay, where you have, this is a negative 3, and you have 1, and you have 4, 3. So you have parentheses here going to the right, and then you have bracket on 1, and you have parentheses on what? Negative 3, because negative 3 and 3 are vertical what? Asymptotes. Okay, so that gives us the solution set in the graph. All right, last example. Okay, it is not like the previous one where the right hand side original equation inequality, the right hand side was 0. And so here we have to do some algebra there. Okay. All right. Now let's go through. First, let's look at the function. Say that solve the inequality 2x squared plus 5x plus 6 divided by x plus 1 all squared greater than or equal to what? Equal to 2. So first thing, we want to rearrange this. Okay. And then we will simplify it. Okay. Let me divide this page into 2 because I need the space. All right. So it means that we are moving negative positive 2 to the other side. So that gives us 2x squared plus 5x plus 6 divided by x plus 1 all squared minus 2 greater than or equal to 0. Now, to solve this, to simplify this, you have to have a common denominator. And so I'm going to have x squared plus 5x plus 6 divided by x plus 1 all squared minus 2 times what? X plus 1 all squared divided by x plus 1 all squared. So that we have what? A common denominator there. Still is greater than or equal to 0. Don't forget that. Okay. And so if I expand, the denominator will be what? Same. Will be x plus 1 all squared. All right. And I have 2x squared mine plus what? 5x plus 6, then minus 2. Now let's expand x plus 1 squared. That will give me x squared plus x plus, sorry, 2x plus what? Plus 1. Okay. This greater than or equal to 0. All right. So let's rewrite this here. We have what? 2x squared plus 5x plus 6, then minus 2 in parentheses, x squared plus 2x plus 1. all divided by what? X plus 1 all squared. We have greater than or equal to that. So let's distribute, remove the parentheses on the what? The second term in the numerator. That gives me 2x squared plus 5x plus 6. And then we got what? Minus 2x squared minus 2 times 2x will be what? Minus 4x. And then that is minus 2 divided by what? X plus 1 all squared greater than or equal to 0. Now some of the terms will cancel out. Okay, 2x squared will cancel minus 2x squared. Then we combine like terms. You get 5x minus that. So you get 5x minus 4x. They have 6 minus 2. Okay, then x plus 1 all squared greater than or equal to 0. So the numerator gives me what? Just x plus what? X plus 4 divided by x plus 1 all squared greater than what? Equal to 0. Now, this function here, this is my f of x, x plus what? 4 over x plus 1 all squared is what? Is equivalent to the original, inequality. Okay. All right. So there's a lot of work in step 1. If you have other than 0 on the right hand side originally, it has some more work, and that's algebra. All right. Now let's go to step 2. Now step 2 is that determine the zeros of the f and the real numbers for which it is not defined. So now my f of x, as we showed you, my f of x is what? X plus 4 divided by x plus 1. Let's write it here. F of x is equal to x plus 4 divided by x plus 1 or what? Or squared. Okay, so zeros of the numerator. Zeros of the numerator. Okay, which will just be what? X plus 4 equal to 0, and then it's x is equal to negative 4. And then the zeros of the denominator. Okay, which is what? It's just what? X plus 1 equals 0, and so x is equal to negative what? 1. Okay, so what would that do? This divides the what? The number line into what? 3 intervals. Okay, so we have that. So that's what step 3 talks about. So we have these 3 what? Intervals, and then we test it like we did before. Okay, so step 4 is that we're going to draw. Okay, we have what? Minus 4, and we have what? 1. Okay, so the intervals again are, we have for negative infinity to negative 4. We have minus 4 to what? Positive 1. And we have 1 to what? Positive infinity. Now, this is the sign of what? Sign of f of x. And what is my f of x? Is what? X plus 4 over x plus 1 all squared. Now, the sign of this f of x depends on only the numerator, because the denominator is squared. And so if you have negative, you square it, doesn't matter. So let's pick test values. You have, let's say, minus 5 for this one. This is 1. So let's use 0 for that. It's easy. And then let's use 2. Okay, let's test it. Okay, it depends on the numerator. So negative 5 plus 4 is what? It's negative. The denominator is always positive. So this will be what? Negative. Okay. If I use 0, 0 plus 4 is positive. The denominator is positive. This portion will be what? Positive. Okay. And then if I use 2 for that, this, like we have, this would be this minus over positive. This side is what? It is positive over positive. And that side will be what? Positive over positive. And so this is also positive. Okay, so what's my solution set? My solution set is what? Everything, because it says it's greater than or equal to, don't forget. See your f of x, which is the what? X plus what? 4 over x plus 1 all squared is greater than equal to 0. Originally, it was greater than equal to 2. So when we simplify, we got that. Okay, so which portions satisfy? It is going to be what? That. But notice that x equal to -1 is a vertical asymptote. So it cannot include, or it makes the function undefined. Okay, so we have brackets on what? On the 4. The solution set will be that, will be s such that, sorry, it does a x is greater than equal to -4, less than 1, and then 1, s is greater than what? 1. Or in the interval notation form, it will be from -4 to 1, brackets on that, brackets on 4, and then parentheses on the 1, union 1 to what? Positive what? Infinity. And the graph is that. Okay, the graph is that. All right. So that is the end of this video, and I'll see you in class. Thank you.